Amazon, just like most other cloud providers, create their own networking equipment, routing equipment, compute equipment. It fits together in a large environment, typically described as software-defined networking, where we have both data and control planes. Starting off with the control plane is kind of interesting because it has to determine source to destination, which path to use for transporting the packets based on your request. And we know the overall platform behind the scenes has to be able to scale up and down based on demand, and there's many different distributed components that make up the Amazon cloud. We also know that there's a global AWS network topology. We've got Route 53 as an Anycast DNS network to help us with overall routing and traffic management, and the software-defined network environment, along with the underlying code that involves routing and security and the overall management of how the traffic flows across the AWS network. If we take a look at the control plane design, we have this overall platform which encompasses, number one, all of the networks that are hosted in all of the different regions. We have a large distributed network topology that the system has to manage. Keep in mind, Amazon really has massive server farms of EC2 instances running custom software, and this custom software manages their control plane, manages their distributed network topology. So if you have multiple AWS accounts that need to communicate, well, there also has to be a baseline security-wise as to what each account can and can't do. So there's a lot of considerations here for before I send that packet or that information to another location, is it allowed? Is that entity that made the request actually allowed to do that? So lots of different components going on here with the control of flow of information across AWS. We also have the data plane, and this is sometimes called the forwarding plane, because after all, I'm usually asking for something. Hey, forward that data to this destination out across the internet or across a private connection. Now, of course, the data could be coming in. It could be ingested through CloudFront. It could be sent to an S3 bucket. There's lots of different motions here, both inbound and outbound, depending on the requests. So the data plane is directing the movement of the data packets based on the request from the control plane. So we have a lot of different considerations when we're looking at these two entities because we have multiple accounts, we have multiple availability zones, and multiple VPC networks. Amazon also has to make the decision, is that IAM user properly authenticated? Are they authorized to carry out that task? Is that EC2 instance allowed to access that storage? Is the proper role assigned to that instance? Is it valid? Compliance logging and auditing are all tasks that could be carried out by a variety of different services that are running at AWS. For compliance, we could be using AWS Config, which manages the overall compliance levels that you want to enforce. Again, in the background, at the control plane level, lots of different services running to check your resources to ensure that they're in compliance. What does it do with that report? Well, it's now going to use the data plane, send that report to an S3 bucket. For logging, we know we have CloudTrail or CloudWatch, auditing also included in the CloudTrail service as well. For storing data records, Amazon also has to be involved in ensuring that the storage is replicated to the multiple pots of data that are required, such as an EBS drive replicating that EBS drive contents to another virtual hard drive, or in the case of an S3 bucket, replicating that content to at least 3 separate buildings and many different locations in those buildings. So lots of things going on below the hood to ensure that Amazon operates as a functioning cloud.